Welcome guys on another tutoring session, and today we're going to be looking at the rules of differentiation. So we're going to look at a couple of them. Today we're going to begin with a general rule, and then we're going to look at an example that applies that general rule, and then we're going to get into other rules as we go on in our sessions. So today I want us to begin on looking at how do you differentiate a function. I'll call this the general rule. So if you are given f of x equal to a to the power x, and the question is asking you to find the derivative. So the derivative is denoted by f prime. So once you see an f prime of a function, it means it's a derivative of that function. So the general application rule of a derivative of a function is given by when you differentiate this. So what you do is you bring down this exponent here and you subtract the 1. So in other words, you bring down this x here, which will become x, and then the same exponent, same base, then you subtract a 1. So that's how you differentiate a function. So let's take an example on applying this rule. Let's say you are given f of x is equal to x to the power 4. So how you differentiate f prime? So you bring down the exponent, so it means it will be 4. X, you subtract a 1, it means it will be 4 minus 3, which will then make it 4x to the power 3. So that's how you differentiate functions. Another example maybe we can take, let's say you are given f of x, it's equal to 3x squared. So when you take the derivative, you say f prime of x. Now disregard the 3 for now. So you just put it there. I will show you as we go into different application rules of differentiation. I will explain further how do you simplify this given two terms that are multiplied to one another. So you disregard, just keep the 3 for now, and then we focus on the x. So the exponent of x here, it's 2. That means you bring down this 2 here. It means it will be 2. And then you subtract a 1. That means it will be 2 minus 1. Which then becomes 3 times 2, which is 6, x 2 minus 1. That becomes your final answer. So hopefully you understood this rule, how it's applied. We're going to be looking at differentiation of a function from first principles. So we're going to use the application of the first principle to find the derivative of this function. And I'm also going to show you an alternative way which you can use to verify if your answer is correct or not. So remember, in our previous episode we covered that the derivative of a function, when you are given a function, is you bring down the exponent and then subtract the exponent by 1. So we're going to first use that to verify the answer that we must get. So when you differentiate here, we must get to the final answer. It must be the same as when you apply the rule of differentiation versus this one. We must get the same answer. So we must verify that the answers are the same. So let's start with this one, because sometimes you might get a question from your exam telling you that you must find the derivative using the first principle. So if the question says you must use the first principle, you have no alternative. But you need to know when you find the final answer that indeed the answer is correct. So if we were to do the direct derivative of this function, if we were to find f prime of x, remember we take down this exponent. So it means we'll have 2x. We subtract a 1 from the 2. That means then it will be 2 minus 1, so which becomes x. Minus, now we move to the next one, 3 minus 3x. We keep the 3. We focus on the x. What is the exponent of x is 1, so we bring it down, so it means it will be 3 times 1, and then we subtract 1, so it means it will be 1 minus 1. What means x will be to the power 0. And then the derivative of a constant, the answer is 0. Now, if we simplify this further, we'll have 2x minus 3 times 1, which is 3. Remember, any number raised to the power 0 is a 1. So which means this is our final answer. Now, when we apply the first principle to find the derivative, this is the answer we must find when we solve. Now, let's apply then the derivative using the first principle. So, the formula for the first principle is given by the limit as h approaches 0 of f of x plus h minus f of x all over h. So this is the formula that you apply. Whenever you do the first principle, this is the formula that you apply. Now, let's start. We know, okay, we start with the limit as h approaches 0. Now we know everywhere you see x plus h, everywhere you see x, you substitute with x plus h. This is what f of x plus h means. So it means in this function, everywhere we see an x, we put x plus h. So which means we'll have, here we have x plus h squared, because we see an x, minus 3, in the place of x we put x plus h, plus 1, this 1. Now we move to the negative, minus f of x. F of x is this same function, exactly as it is. So it means we'll have x squared minus 3x plus 1, all over h. Now we must simplify out this numerator so that we can be able to simplify it. This will then be the limit as h approaches 0. If we simplify out this bracket, you know how to multiply brackets using the FOIL method. First, you will expand the brackets. We'll get that. You look at that when you cover exponents. So how you simplify this? This will be x squared plus 2xh plus h squared. Minus, now you multiply, you distribute the 3 to this bracket. This will become minus 3x minus 3h plus the 1. Now you multiply by the negative to simplify out the bracket. Then you'll have negative times positive, which is negative x squared. Negative times negative, which is positive 3x. Negative times positive, which is negative 1. And then all over h. Now we look for like terms. I'm sure by now you can see that there are terms that are cancelling one another. X squared is cancelling x squared. Minus 3x is cancelling 3x. Positive 1 is cancelling minus 1. We are then left with the limit as h approaches 0 of 2xh plus h squared minus 3h all over h. Now we can see we have a common factor in the numerator, which is an h. If we take out the common factor of h, we are then left with, when we divide here, we'll have 2x plus h squared divided by h, which is h, minus 3x divided by h, which is minus 3, all over h. The h then cancels out. We are then left with the limit as h approaches 0 of 2x plus h minus 3. Now in the place of h, we substitute 0 as per the limit. We'll then be left with 2x plus 0 minus 3, which becomes 2x minus 3. This then becomes the final answer. You see, the answer is the same as the answer we found there at the top. So this is how you differentiate using the first principle method. Thank you.